Today's lesson is polar coordinates. So my learning objective for today is I will plot points in the polar coordinate system, convert points and equations from polar form to rectangular form, and from rectangular form to polar form. Okay, so at this point, we've only seen a Cartesian coordinate system where I have an XY plane where the lines are horizontal and vertical. So I'm introducing a whole new graphing system that has circles, and these are in polar coordinates. So I'm going to start out by talking about I have the rectangular coordinate system. My horizontal is my x coordinate. That's my x-axis. And my vertical is my y coordinate, which is my y-axis. Okay, and we should be pretty familiar with those. So if I have this point 2, 2, I'm going to go 2 to the right and 2 up. So I know that my x coordinate, so x is here, if I draw this in like this, I know x is 2, and my y coordinate is 2. So I know y equals 2. So if I apply the Pythagorean Theorem, I know that these are 45-degree angles. I know that I am perpendicular, so I know this is a 45, 45, 90 triangle. So we've been working with 45, 45, 90 special right triangles in the unit circles since December. So I should know that my ratio is 1, 1, and the square root of 2. So the two legs are the same, and the hypotenuse is the leg times the square root of 2. So I know that we call this the radius. So I know if my legs are 2, I know my radius is 2 times the square root of 2. I know my reference angle is here, and I know my angle is 45 degrees. Okay, so I'm just talking about plotting a point on my standard Cartesian coordinate plane. Well, this is on this polar graph. This is the exact same point, and I just chose polar graphs instead of rectangular graph. So it looks very similar. So this is the exact same point. I turned one graph on and the other graph off. So we're going to learn now. I have a polar axis, or a pole and a polar axis. So the pole is the center here, and then the polar axis is going to be what I would have called the plus x-axis. Okay, so here's my polar axis here. Okay, so if we're thinking about when I'm counting stuff and I'm rotating things, I know that my positive direction is counterclockwise and my negative direction is clockwise. Okay, so I have my coordinates are x and y for my rectangular coordinates, and in my polar coordinates, my coordinates are r and theta. So I've been really working with r and theta all along on this rectangular coordinate here. So the r I'm referring to is the hypotenuse of my triangle, and theta is my reference angle. So I've been really working with these for quite a while now. Okay, so if I look at 2 times the square root of 2, if I multiply that out, that's approximately 2.8. Okay, so 2 times the square root of 2 is about 2.8. And if I say the radius is one level, so this is be one radius, 2 radii, 3 radii. So each circle is 1 r. This is going to be 2.8, so it's almost 3. So if you see, I'm at almost 3. Okay, so let's work with this. So let's name this point a couple different ways. So let's go back to, so this is my negative direction. I'm going to put these on here right away. Here's my positive direction. Just for reminders. And my polar axis. So I start counting here. So my 0 is this positive x axis. And I call that my polar axis. Okay, so let's name the polar coordinates and 2 coterminal angles. So if I'm counting, I want to know what each of these lines represents. So I'm going to start out with, I know that halfway around is 180 degrees. So I want to know what is each mark represents. So if I can count it, either count up how many sections I have for 360 degrees and divide, or I can count by 180 and divide by just counting half, or I could count 90. If I count 90, so I have 1, 2, 3, 4, 5, 6 equal parts. So if I take 90 degrees and divide that by 6, I'm going to get 15 degrees. So each of these marks is representing 15 degrees. So if I'm 180 here, this is going to be 30 degrees here. So counting in the positive rotation, this is 210 degrees. If I count this in the negative rotation, this is really going to be negative 90 here, right? This will be negative 90 degrees, and it's going to be 180 minus 30. So this would also be negative 150 degrees. So this is either positive 210 degrees or negative 150 degrees. Now, if I want to count out how many radii this is, so I count from the pole. So then this is going to be 1, 2, 3, 4, 5, 6, 7. So I'm counting 7 out. So my radius is 7. And in the positive rotation, that's going to be 210 degrees. Or if I count in the negative direction, I can say this is 7, negative 150 degrees. So these are coterminal. So I have one in the positive rotation, one in the negative. It's asking me for a third one. So if I take 210 and add another whole rotation, so a whole rotation is 360 degrees. That's going to be 570 degrees. So I can say another rotation is at my radius of 7 and 570 degrees. Okay, so we're just kind of tying in several things together. Oops. Let's try the same thing, but now I'm going to introduce my radius in the opposite direction. So my plus radius is considered towards the angle, and my minus radius is 180 degrees away. So if here's my point here, how come it's not letting me highlight here? Not sure why that's not letting me highlight. Okay, so let's try this. So here, this is the line I'm talking about. So towards the angle is where the point is, and then 180 degrees away. So counting in the positive rotation, these are still 15 degrees each, that this is going to be, this is 180 degrees here. So 15, 30, 45. So that's going to be 225 degrees in the positive rotation. And then on the other end, I'm talking about in the positive rotation, this is 15, 30, 45. So this is 45, the 45-degree angle here. When I'm counting in the negative rotation, this is minus 90 and 15, 30, 45. So 90 and 45 is going to be negative 135 degrees in the negative rotation. And if I'm counting in the negative rotation here, this is going to be 360 minus 45. So this is negative 315 degrees. Okay, so now let's talk about, so a positive R, I'm going towards the angle where the point is. So this is going to be my positive R, and my negative R is going to be in the direction that's 180 degrees away. Okay, so positive R is towards the angle, negative R is away 180 degrees away from the angle. Okay, so what does R equal? So R, so I have four scenarios I can have. I can have a positive R and a positive angle, positive R and a negative angle in the negative rotation, negative R in the positive rotation, and negative R in the negative rotation. So let's start out with the positive R. So counting out how many rings. So my radius is going to be 1, 2, 3, 4, 5. So I know R is 5. So in the positive direction, it's 5. And then this is my positive theta. So this is 225 degrees. And we're working in degrees. So my positive R in my negative rotation, this is negative 135. So this is in the negative rotation. So negative 135. Okay. Now let's talk about this in terms of negative R. So if I'm talking about over here, so this is negative 5. So I'm talking about this axis over here. So in the positive rotation, so the 45 is the positive rotation. So this is going to be negative 5, positive 45. And then in the negative rotation, negative 5. And my negative rotation at this angle is negative 315 degrees. Okay, what I want to make sure it's really clear is these are not the same angles. One is a plus number and one is a minus number. That's probably the biggest mistake I see. So when you're setting these up, I would do it just like I did. I would label where the point is, what this angle is in the positive rotation, and then in the negative rotation. and then draw the line 180 degrees on the other side and do the same thing. What is this angle in the positive rotation and in the negative rotation? And I know the positive x-axis is my 0. All right. How do I switch back and forth between these two systems? So my point xy corresponds to the point r times r theta in my other system. So these two are related, and we've been really working with them all along. All right, so for my rectangular coordinates, to go from xy to r theta, I'm using the Pythagorean Theorem. So I know r squared equals x squared plus y squared because I have a right triangle. So I'm going to take the square root of both sides. So simplifying, when I take the square root, I know I have a positive and a negative. So this is where this is going to be plus or minus the square root of x squared plus y squared. So here's one of my equations. And then to solve for my angle, I usually write this as tangent. So to solve for the angle, I'm actually going to take the inverse. So theta is the tangent inverse of y divided by x. Okay, so if I'm given r and theta to calculate, if I'm given x and y and I need to calculate r and theta, these are my two equations. Or if I am given r and theta and I need to calculate x and y, I'm just using my standard SOHCAHTOA. So cosine is adjacent divided by the hypotenuse. So I'm solving for x, so I'm really just cross multiplying these. So this is going to be x equals r times the cosine of theta. So I put r to the left of the trig word. And sine is opposite divided by the hypotenuse, which is y divided by r. So again, I'm just cross multiplying. So y equals r times the sine of theta. So I'm just using my standard trig. Okay, so let's do a couple examples now. Number 1, find the polar coordinates for the point 3, 4. So I want to know what is r and theta because I'm been given x and y. Okay, so I'm going to just draw my triangle. So x and y are both positive, so I know I'm in the first quadrant. So I know x is 3, y equals 4. So r is the hypotenuse, and theta is this angle here. So substituting in, I get r equals the square root of x squared, which is 3 squared, plus y squared, which is 4 squared. So 3 squared plus 4 squared, I should recognize this is a 3, 4, 5 right triangle. If not, I can have 9 squared plus 16 squared is 25. The square root of 25 is 5. So r equals 5. So right now I'm just going to do the positive r direction. And then my angle, theta, is going to be the tangent inverse of y divided by x, so 4 divided by 3. So if I'm doing this in degrees, you need to pay attention to your mode. So I need to know if I'm doing this one in degrees. So if I put my mode in degrees, I'm going to round 2 decimal places. I would get theta equals 58 58.13 degrees. So I would write this as 58.13 degrees is my r theta coordinates. Okay, let's try another one, not in the first quadrant. Okay, so just draw a sketch. So 4, -4. This puts me in the fourth quadrant. So I know x is 4, y is -4. Here is my angle. Here's my radius. Okay, so to solve for r is the square root of x squared. So 4 squared plus y squared, -4 quantity squared. So this is going to be 2 times 16, which is 4 times the square root of 2. So this is my exact answer. And my rounded answer is going to be about 5.656. Okay, my angle theta is going to be tangent inverse of y, -4 divided by 4. So when I put this in, this tells me my angle theta is -45 degrees. If I want to say that in the positive direction, that's going to be 360 minus 45, so that's also 315 degrees. So I can state my answer a couple different ways. I can say my answer is, because I'm looking for r and theta. So with my exact answer, I can say it is 4 times the square root of 2, 315 degrees. I can also state this as 4 times the square root of 2, -45 degrees. Or if I want to round this, I can say 5.656. And I could say either 315 or -45 degrees, but I'm just going to put the -45 since that's what my calculator came up with, the default. I just have to understand what my calculator is telling me. Okay, so that's finding the polar coordinates given the rectangular coordinates. Well, let's do this one the other way around. So this time I have the rectangular coordinates, and I want to know, I'm given the polar coordinates, I want to know what are the rectangular coordinates. So, okay, so this is r and theta is what I have. So I want to know what is x and y. Okay, so I am going to sketch this. So I have, this is going to be 330. So 30 degrees, whether I'm talking about the polar or rectangular coordinate, I know it's going to be in the first quadrant. So this is 30 degrees. My radius is 3. So I'm solving for x and y. So my equations are x is r times the cosine of theta. And we said theta is 30 degrees, so r is 3 times the cosine of 30 degrees. The cosine of 30 degrees is the square root of 3 over 2. I want the exact number. So this is exact. If I round, this is going to be about 2.598. So solving for y is r times the sine of theta. Substituting r is 3, sine of 30 degrees. So the sine of 30 is a half. So 3 times a half, which is 3 halves, or 1.5. I don't have a rounded value, so I can write my answer a couple different ways. So I can say exactly that this is 3 times the square root of 3 over 2, 3 halves. I can say this is, oops, I wrote square root of 3. 3 times the square root of, it is square root of 3. I'm sorry, I had that right. Square root of 3. 3 square roots of 3 divided by 2, 1.5. Or I could do this rounded and say 2.598. And if I'm using this as decimals, I would probably show this as a decimal rather than a fraction. So multiple correct ways to answer. Okay, so next, let's switch equations back and forth. Okay, convert the equation y equals x squared to polar form. So that means I don't want any x's or y's. So I'm going to substitute in. I know y is r times the sine of theta. And x is r times the cosine of theta. But x is squared, so we're going to square this. So now I'm going to apply the squaring to both terms inside. So this is r times the sine of theta equals r squared cosine squared theta. So I could be either answer. It depends how far you're taking it. Okay, let's do it reverse. I want to convert the equation r equals 4 cosine theta to rectangular form. So that means no r's or thetas. So I have r equals 4 cosine of theta. So I'm going to start out by multiplying by r. Whatever I do to the left side, I do to the right side to keep my equation equal. So this is r squared. And then I'm going to rearrange, and I'm going to put this with the r in front of cosine. So 4 times r cosine of theta. So I know r cosine of theta is x, and I know r squared is x squared plus y squared, so 4x. Here we go. I got rid of r and theta. That's it.